Division is known as fair share. There's a few ways of representing division. 14 divided by 3 as a fraction, 14 divided by 3, or using this symbol where 14 is divided by 3. And what we mean by fair share is if I was looking at 14 divided by 3, we have 3 equal groups in which we're going to divvy 14 up into. So if I put 4 in each group, I have used 12 of my items. If I put 4 in each group, I have used 12, and I have 2 remaining. We're going to right now leave that remainder just as an R for remainder. So we're going to focus on the third representation of division. We're going to do it by a scaffolding technique. Scaffolding is going to look like this. I look at this 6, just as you have in your regular long division. I'm going to look at that really as a 60. And I know 10 times 4 is 40. So I've used up, each group will get 10, and I've used up 40 of them. I have 24 remaining. Now the numbers become smaller. I have 24 remaining. I'm going to divide them up into the 4 groups. And I know from my multiplication, 6 times 4 is 24, with nothing remaining. Each group gets 16 items, because there were 64 total, and I was dividing those into 4 groups. If I have 240 items, and I'm dividing it into 5 separate groups, what I'm going to try to do here is ask myself 240. I'm just going to look at the 200. And I know that 20 times 5 is 100. So if each group got 20 of those items, I would have 140 remaining. Well, I know if I have 140 remaining, again, I can put 20 additional into each group. That takes care of 100 of them. I have 40 remaining, and 8 times 5 is 40, so each group will get an additional 8. So each group then has a total of 48. And to check this, I can use multiplication. 48 times 5, well, 8 times 5 is 40. 5 times 40 is 200. 240 is the total amount. So multiplication and division will check each other as they are inverses of each other. Let's try another one. I see a 538. Well, I know 4 goes into 500, so notice I'm just picking that first left-hand place value, which is the hundreds. 4 goes into 500 100 times. I've used 400 of the objects. I have 138 remaining. I'm looking at the 100, and I know there are 4 quarters in a dollar, so 25 times 4 is 100. I have 38 remaining. If I have 38, I'm going to divvy up into 4 groups. Each group will get 9, because 9 times 4 is 36. And now I have 2 remaining that I can't fair share at this point until I break them into pieces. So each of those 4 groups will end up with 134, and I'll have remaining 2 sitting out there that I haven't done anything with. The 134 came from adding the scaffold. 125 plus 9 is 134. In the last problem, this is a 2-digit into a 4-digit. It works the same. I look at this number 3, and I see it as a 3,000. And I know 15 times 2 is 30. So 15 times 200 is 3,000. I've used 3,000 once I've put 200 in each of the 15 groups, and I have 246 remaining. If I want to multiply by 10, that might be the easiest. I always like to do the tens and hundreds. 10 times 100, or 15 is 150. Subtracting, regrouping so that I have enough tens. 50 from 140 is 90. Now when I look at the 96, well, I know 15 times 2 is 30. Maybe that's the largest that I saw. It's still going to work because we're going to do that one more time and take out another 30. And I'm down to 36. Oh, I'm going to do it a third time, and that should be a 2, which gives me 30, and I have 6 remaining. So each group then receives this whole, which is 200, 10, 11, 12, 13, 14, 15, 16, 216, and there are still a remaining 6, not enough to give each group another whole.